Hello, this is Mrs. Decker, and this is Objective 1C, and this lesson we're going to do three-step problems. So we're going to convert between number of particles, mass, and volume between two different substances involved in a chemical reaction in three-step processes now. So before we get started with three-step, we want to do a review of the two-step we learned in the last lesson. So go ahead and pause the video and do this warm-up and come back for the answer. Alright, how many moles of KCl is produced from 2.5 grams of potassium and excess Cl2? So our given information is this 2.5 grams of K. So we're starting off up here at mass of our known substance, and we want to know how many moles of KCl. So we want to go here to moles of our unknown. So the first step will be to go from mass of the known to moles of the known, and then step 2 will be to go from moles of our known substance to moles of our unknown substance. So excess Cl2 is extra information that we don't need right now. So go ahead and write your given information. And first we want to use the molar mass to go from mass of potassium to moles of potassium. The molar mass of potassium is 39.10 grams in 1 mole. So now we're at moles of potassium. We want to go to moles of KCl. So we're going to use the mole ratio from the equation. So it's 2 moles of K to 2 moles of KCl. And that gets us to moles of KCl, which is what we're looking for. Grams of potassium cancels out, moles of potassium cancels out, and we're left with moles of KCl. So you're going to do 2.5 times 2 divided by 39.1 times 2. And your answer should be 0.0639 moles of KCl. Remember, we want 3 sig figs, and you need to label the units and the compound. Alright, now here is example 1 of our first three-step problem. Determine the mass of water produced from the decomposition of 25 grams of NH4NO3. So we're starting off at mass of our known substance, and we want to know the mass of our unknown substance. So we're going to go from mass to moles of our known substance, then moles of our known substance to moles of our unknown substance, then moles to mass of the unknown substance. So we have 1, 2, 3 steps. So first step is to go from mass to moles. We need the molar mass of NH4NO3, and it is 79.97 grams in 1 mole. Alright, now we're at moles of NH4NO3, and we want to go to moles of water. So we use the mole ratio from the equation. So there's 1 mole of NH4NO3 to 2 moles of water. Now we want to go from moles of water to grams of water. So we're going to use the molar mass of water. So grams of NH4NO3 cancels out, moles of NH4NO3 cancels out, and moles of water cancels out, and we're left with grams of water, which is what we want. The answer is 11.2 grams of H2O, because you need to do 25 times 2 times 17.99 divided by 79.97. Example number 2 says if 5.6 times 10 to the 24th molecules of nitrogen reacts completely with hydrogen, what mass of ammonia is formed? So here we are starting off at molecules of nitrogen, and we want to find the mass of ammonia formed. So we're going to go from molecules to moles of nitrogen, then moles of nitrogen to moles of ammonia, then from moles of ammonia to grams of ammonia. So write your given information. And we want to use Avogadro's number to go from molecules to moles. Okay, now we're at moles of nitrogen. We want to go to moles of ammonia. So you're going to use the mole ratio from the equation. So it's 1 mole of nitrogen to 2 moles of NH3. So molecules of nitrogen has canceled out, and moles of nitrogen has canceled out. We're at moles of ammonia, and we want to go to grams of ammonia. So we're going to use the molar mass to do that. And the molar mass of ammonia is 17 grams. So moles of ammonia cancels out, and we're left with grams. So it's 5.6 times 10 to the 24th times 2 times 17 divided by 6.02 times 10 to the 23rd. And remember, when you're dividing by scientific notation, to put the whole thing in parentheses so that your calculator calculates correctly. And when you do that, you get 316 grams of NH3. Example number 3 says, when 100 grams of C2H6 reacts with excess oxygen, how many liters of carbon dioxide are produced? So we're starting off with mass of C2H6, and we want to find out the volume of carbon dioxide. So we're going to go from mass to moles of C2H6, then moles of C2H6 to moles of carbon dioxide, then moles of carbon dioxide to volume of carbon dioxide. So write your given information. And we want to use the molar mass to go from grams to moles of C2H6. So grams cancels out, and now we want to use the mole ratio to go from moles of C2H6 to moles of CO2. So it's 2 moles of C2H6 to 4 moles of CO2. So moles of C2H6 cancels out. Now we want to go from moles of CO2 to liters of CO2, and to do that, we use the conversion factor that 1 mole of CO2 gas is equal to 22.4 liters of CO2 gas. So you'll do 100 times 4 times 22.4 divided by 30.02 times 2. And you want to make sure that if you're putting it all in one line that you put parentheses around what you're dividing by. And your answer is 149 liters of CO2. Again, remember 3 sig figs and your units and compound. Okay, and our last example problem says how many molecules of hydrogen are necessary to react completely with 50 liters of nitrogen gas. So here we're starting off at volume of nitrogen gas, and we want to find out how many molecules of hydrogen are necessary for that. So we want to go from volume of nitrogen gas to moles of nitrogen gas, moles of nitrogen gas to moles of hydrogen, then moles of hydrogen to particles of hydrogen. Okay. To go from liters to moles, we use the conversion factor that 22.4 liters of nitrogen gas is equal to 1 mole. So liters cancels out. Now we want to use the mole ratio to go from moles of N2 to moles of hydrogen. So moles of N2 cancels out, and now we want to go from moles of hydrogen to molecules of hydrogen. So we're going to use Avogadro's number to do that. Okay, so you do 50 times 3 times 6.02 times 10 to the 23rd divided by 22.4. And that gives you 4.03 times 10 to the 24th molecules of hydrogen. So now that I've gone through these example problems, there are 12 problems in your packet for you to practice, so go ahead and do that and let me know if you need help.